name is Today I am going to explain you about British HLS design flow. So that design flow containing three parts. The first one is simulation, second one is synthesis, and third one is implementation. Okay. So first of all, just install that British HLS. I already installed it, so it is having this type of interface. Okay. So after installation, just open that British HLS design flow and go to that create create project. Okay. In that create project, there is one interface come where you can write your program name. I am going to take example of matrix multiplication, so I take a program name like that matrix mul. So this is the location where I am saving that file. Now click next. Now go to that search bar and select your board. I am using ZYNQ 700 board, so I am using I am selecting that board. After that, there is an interface comes. Okay, that interface contains this type of interface. Basically, this type of interface comes where it includes four folders, and first folder is that includes this folder containing the header file, which is .s file, and the second is source. So this folder containing .cpp file where I am going to write all the logics related to my program in C language and in C, and after that the test file where I'm going to give a input and expected some output uh, by related to that. And here is the solution. Here I in this folder I can see all my output. Okay, and all my solution or all my result. Okay, after the implementation of the program. Okay, now first of all I am going to give you a brief about that code which I wrote. So first go to source file, click on add source file, and just give your program name as mat- matrix multiplication.cpp. So this is a short form which I used earlier. So here I include that one header, and from where this header comes, that header comes from dot includes file. Okay, so I made this program. This program contains three matrices. The first one is A matrix, the second one is B matrix, and the last one that is a result matrix, which and and each matrix having classes like A matrix having matrix class, B matrix having matrix class, matrix are having matter class. Okay, so this is the logic of that program. Okay, that how matrix and matrix will multiplied with each other. So now for the header file, in the header file I am just defining the number of rows and the number of column of both the matrices and how my resultant matrix looks like. Now the third one is that test bench. Okay, so in the test bench folder, I am going to give you an input of matrix A and matrix B and expecting some results which I am going to store in HWDZ. Okay, and I am also going to make a 2 by 2 matrix of HW result. Okay, so in the HW result, I I write the code in the test bench itself, and I am putting all the resultant in SW result matrix. Okay, and and that HW result is used, and that HW result matrix is used to call that mathmal function from the source file. Okay, so from here we are using that mathmal function. Okay, so after that I am going to just see the whether that this SW result and SW result are equal or not. If both are equal, then I am going to say that the test is passed. If both are not equal, then I am going to calculate the error. And here I print the total number of error by using this function. Okay, so as you see, include contents that dot header part. Okay, source conclude that source include that cpp part. Okay, uh, now source include that cpu part. Here the main logic is written here. Okay, after that go to the project and run C simulation. Okay, after that wait a few seconds. It will take 2 to 3 seconds. Okay, yeah, yeah, now see, after running it you can see like this is a test pass, and after multiplying both the matrices, that uh, this one mat A and mat B, the resultant matrix look like this. Okay, where is that? This one. The resultant matrix looks like this. Okay, after that just go to the solution part and just synthesis this. So I am using that synthesis, run synthesis. So after that it will it will also take some time. So wait a second. It is running fine. Yeah, it is analyzing our file mat.cpp. Okay, now yeah, this comes the window. Okay, so here you can see this is the memory which is used by this program. This is that top level control which is used by this program, and here this is the matrix multiplication file which we are going to which I made. Okay, so now here the main thing is the latency and interval. Okay, okay, after that so this is the synthesis part. Now I'm going to run the core simulation part. Okay, so here you can select Fedilog, this one is none, and click the OK. Okay, it will take some time. Wait a second. It will take some time. Yeah. Okay, now you see here the test cases fail. So the question is why it is failing? Because it is failing because your laptop contains some antivirus tools. So first of all, go to your antivirus tool and disable for few minutes. So here is that disable. I am going to disable it for 1 hour. Let's see. Now once again, I am going to run the code simulation. Yeah, now it will take some time. Wait a few seconds. It is compiling. Okay, our program is compiling. Yeah, now you see the status is pass. Okay, uh, so so here you can see our maximum latency and minimum latency just 1818, and the average latency is also 18. Okay, basically it is used to check our design after the C simulation. So the status is pass here. Okay, after that now go to that once again that solution and yeah, open scheduler. Okay, so here you can see the how your logic works. So if I am going to click this one, so this is shows how this one is matched from each other. Okay, and if I am interested that from where it comes from, then just right click here and go to sources. Okay, in source courses there is this one blue line, so it is implementation, so that logic implementation comes from that line. Okay, so basically yeah, just see here, this one is from where this one is comes from. So just go to source and just click on. Okay, So this one is comes from here, and it is having mapping in such a way. Okay. Now the last thing is just export this file. So just go to that export RTL and click here. Okay. So now I am going to that. This is the DSTL. I am writing in just such a way that if my lab name is something right, so I am writing mentioning that lab name here, and this is the display name. Okay, I am going to click OK. Now it is taking some time. It will. It is checking that everything is correct or not. It will take some time. Yeah, wait a few seconds. Yes, the exportation is completed, and so this is the basic flow of that VT's HLS. So that is all from my side. Thank you.